Good morning, good evening. Namaste. Today we are going to continue with our new session related to machine learning algorithms. In that, we will be working on unsupervised learning. In the previous session, you learn about supervised learning, and you have understood. I hope understand what the algorithm will come under supervised and how it is different from uh, each other and their algorithms, so on and so forth. So, in unsupervised learning, we'll continue working on that in today's session. Okay, so what is the goal? So the typical supervised learning goal is it is very important example I can give you to understand how an unsupervised learning will help you to identify patterns in a group of similar data points together without any predefined labels or categories which are associated to it. So the main aim is here to partition a data set into different clusters such that the data points within the same cluster are more similar to each other than those in that of other clusters. Okay, so let's assume. So why I say data points of same thing is different from other things. Take a basket full of different fruits, and we will see what kind of fruits based on their characteristics, how we can cluster based on similar characteristics. Okay, so before that, we will see what type of supervised learning techniques are available. So we have clustering, which is nothing but grouping similar data points into clusters based on their inherent similarities. Whereas in dimensionality reduction, this is another type of unsupervised learning. You get to see what do you mean by dimensional reductions. So how many dimensions you have? There can be huge data, unstructured and structured data, which contains n number of dimensions, thousands and thousands, and you need all dimensions are not required. All variables might not be required to understand um, the data, and in order to do that, in order to get into specific conclusion, you have to reduce the number of input variables or features while preserving importance of each individual features. So let's say take an example, a simple mathematical example. In 7th class, say standard, you will be knowing A gives rise to B gives rise to A gives rise to C. So there are three scenarios. A is associated and A subsequently gives rise to B and B gives rise to C. Say similarly, I can say A is A to C. So these are three are variables. So just understand what is the significance of A to C. We have A to B, B to C. A to C is the derived variable, right? So those kind of variables we have to remove it when we do data preprocessing, so on and so forth. The third type of unsupervised learning is association rule learning. Association is nothing but the fancy term we tend to call this market basket analysis or a priori algorithm where we want to see how one particular usually we typically we use this in retail or different types of marketing scenarios where if a person buys one particular object, what is the chances of buying another object along with this object, right? Go to a shop and try to buy a curd, and then typically you will see other milk products, okay, associated. Then they will be near to that curd specific thing, and the same way positioning or placing all these products in the supermarket. This is based on the association rules. So you have supplementary products, you have complementary products, so on and so forth. When we will discover that, we will learn that when we get into association rule based learning. Okay, the fourth one is of type anomaly detection. It's another type of unsupervised learning, nothing but outlier anomalies in a specific data set. Can identify an outliers or rare items. Simple example is you are going to a specific place every day at 5 o'clock. Suddenly on Monday you went at 10 o'clock. So if you look into the pattern of these variables, the 10 of the variable where you went to temple or to the home or one place at 10 o'clock will be the outlier because it will not fall in the same pattern. So anomaly detection. This is another type of unsupervised learning. We'll go further. What is clustering and how it is um, important in this scenario. So how do we do? What is the definition? And how what is our major objective for doing clustering? As I told, it's unsupervised learning, and the main aim is to partition the data set into different clusters based on their similar properties or groups, I can say. So there are several algorithms. Typically, there are 4 or 5 algorithms are there, and we typically concentrate on these three: centroid-based clustering, density-based plus clustering, and hierarchy-based. Okay. So I will take you through one such scenario, centroid-based clustering, and we'll understand this particular how does this particular clustering works in overall, and we will get into a scenario where how a small application can be created based on centroid-based cluster. Okay. So for this, we look into this algorithm includes k-means. Um, K-means as our algorithm, and it determines the clusters. Basically, centroid. You must have a remember in school we have when we tried looking into the triangles, and there is a center point of an equilateral triangle or any triangle. Centroid, we say equidistant from all corners, all places, so that we call a centroid. And we try to create this centroid of nearest centroid based on a distance. Distance, we have several distance methods. Typically, we look into Euclidean distance. Over here, Euclidean distance, you must be aware of it. Distance between 2 points, x1, y1, and x2, y2. You know the distance formula again with mathematics. And the second one is of type density-based clustering. DB identify regions of high density in the data space and assigns points to cluster based on connectivity. So you will be having this particular based cluster. And hierarchy clustering, you know the what is hierarchy? You will have a tree-based structure where you have a root node and then child nodes further drill down to a final leaf nodes. Okay, so this is one type of clustering, right? And we have several, there will be these distance metrics which we usually use: Euclidean distance, cosine similarity, and just to understand what kind of a distance between these 2 points. Okay. So what typically we do? We have to do data pre-processing. Typical, take any example. We need to do data pre-processing, and then we have to choose the right algorithm, and then we have to select the technique to do the feature selection. And then we do model training, and then we have to interpret the results. And then we do post processing of post processing and visualization of this particular scenario. Okay. The typical applications where we use uh, the clustering, unsupervised learning, is customer segmentation. It is so you can see the word segmentation, grouping of customers based on their specific behavior, whether it is purchasing behavior, or whether they are footfalls, or whether they're demographics, or whether they are spending capability, or purchasing or income based, so on and so forth. Another type is image segmentation. Some of them are anomaly detection. Some of them are document clustering. Different types of clustering based on their topics. And then recommendation ecosystems, grouping specific users and or items based on similarity for personalized recommended systems. So you can say you may need to buy this particular appliance or this particular uh, thing, and those kind of recommendations being generated based on these particular clustering techniques. Okay, let's explain. Let's see. We will I will explain you a simple to collect example. We will look into it. And then the limitations you need to have. There are of course as usual you have several limitations and challenges where you will be seeing a right number of clusters is one important thing, and it is a challenge also. You won't be knowing. You will be looking into you will be understanding the distribution of this particular data, and then you will use several methods, elbow method or silhouette analysis, so on and so forth. So how the data is patterned, so on and so forth. So that is a little challenge over here. And then if the data is having high dimension, then it will be very difficult to cluster. And the same thing, interpretability and validation is kind of subjective, I can say. So I may interpret but so it's a little difficult, but it is not impossible. I will take you through these things. These are the areas where you need to understand how where our algorithm faces a challenge. Okay, so let's get into these are all sample real world examples. I will take you through um, to one of the clustering scenarios. So this is very simple. The objective of this particular thing is I have five different fruits. Okay, apple, orange, banana, grapefruit, and kiwi. So this is based on weights. They call what should I say? Uh, the weight in grams of each and individual fruit, and the this is the sweetness rating. So very simple. I have used NumPy and Matplotlib to understand this particular scenario. This is the fruits named array I've created, and here I have to define my x and y variables so that so I took the first set of the array and second set of the array as sweetness, and I'll just run it. You will see how they are. Okay. Simple. In our previous example, we have explained how a scatter plot should be drawn. Okay. So you can see this is the weight of the kiwis, apple, banana, orange, and grapefruit. This is how I have created scatter plot and I have tried looking at it. So what to do? As I told, we have to understand the distance between similar groups. So I have to group these fruits based on their sweetness and based on their weights. So then I have created. So this is k-means clustering. I've created similar fruits. These three are of same type, and these two are of same type. This is how the output comes. Okay. And the same thing, I've used hierarchical cluster using dendrograms. You can see these three fruits become grouped under same parent, and these other grapefruit and kiwi will come under same leaf. So based on their characteristics. So just same thing here. I have just defined Euclidean distance and k-means clustering using the centroid. I've created centroid arguments out here. This is just a simple centroid program, and I tried visualizing these things. Okay, so in the end, you have to interpret how many clusters have been created. Two clusters have been created, cluster one and cluster two, based on their weights. I can say again, I can say these cluster one. So you have all these things, and cluster one, I will say this and this, where apple and apple, banana, and kiwi. These fruits are of moderate weight. You can see the weights, and then but high sweet, whereas the other two clusters, grape as well as orange, they've been clustered in a similar cluster with lower sweet and I can say a little heavier wheat. Okay, so that is how we interpret, right? So yes, this is how we will proceed. And again, these are the further steps. And please keep following our channel. Thank you. Thanks for subscribing. Have a great day.